So let's start with level 0. You are an island. You are in a void of your own making. The main question you wonder is, why? Why am I disconnected? Why did I choose to remove myself from everyone else? See, at this stage, you have no connection to anyone. No Ethernet cable glowing, no Wi-Fi signals dancing in the air, no networks responding to your calls, just silence and an eternal void. It is the ultimate digital isolation. To escape the digital solitary confinement, we must understand the very basics. Let's start with Ethernet and switching, the foundational building blocks that bring light to the void. The IEEE, that's the Institute of Electrical and Electronic Engineers, is the global authority. They set the standards for all network communications, ensuring devices from different manufacturers can talk. Without them, our networks would be chaos, and you'd be stuck forever at level 0, adrift in that silence. It defines how devices send and receive data over physical cables. Think of Cat5, Cat6, and Cat7, the familiar wires connecting your computer to your router. It dictates speeds like 10, 100, and 1000 megabits per second. In short, it's the bedrock that makes wired networking possible and reliable, offering your first tether back to the world. Even when a physical connection is made, communication isn't guaranteed. When two Ethernet ports connect, they don't just plug and play blindly. They smartly negotiate the best possible connection and parameters. This includes the crucial speed of the link, like 100 megabits per second or 1 gigabit, and also the duplex mode. Whether it's full duplex, sending and receiving simultaneously, or half duplex, which is one way at a time, this intelligent handshake process is called auto-negotiation. It ensures both sides speak the same digital language, preventing frustrating mismatches that could leave your new connection lifeless, pushing you back towards that disconnected feeling. They encapsulate your precious information and carry a label telling switches exactly where it's going. An Ethernet frame isn't just data, it's a structured package. It includes a preamble to synchronize from a start frame delimiter, the destination MAC address, and the source MAC address. Then comes the length type field, followed by the actual payload, your data, your message to the outside world. Finally, a frame check sequence, or FCS, for crucial error checking. If this FCS doesn't match, the frame is dropped, preventing corrupted data from passing through. This unseen failure can prevent your message from ever arriving, maintaining your level 0 isolation. To truly connect, devices need to identify each other. Every single network device, from your phone trying to reach Google to a massive server, has a unique MAC address. MAC stands for Media Access Control. These addresses are burned directly into the network interface card, or NIC, at the factory. Switches use these unique addresses to decide exactly where to forward frames, ensuring your data reaches its intended recipient. MAC addresses are like digital fingerprints for devices. They are globally unique, ensuring no two are alike across the entire world, making them essential for breaking out of that void. You see, switches are clever. They learn MAC addresses dynamically. They build their internal forwarding tables by observing the source MAC addresses of incoming frames. When a frame arrives, the switch knows which port it came from and associates that MAC with that port. If the switch doesn't know where a specific destination MAC address is located yet, it doesn't just give up. It floods out the frame to all ports except the one it came in on, like a desperate shout out into the dark. Once the destination replies, the switch learns its location and updates its table. Then on subsequent packets, the switch forwards it directly, efficiently ensuring your voice is heard, no longer lost in the void. Once connected, how does traffic flow? Switches can forward frames in 3 distinct ways, depending on the destination. First is unicast. This is a one-to-one communication, like a private conversation with a single friend, the most direct path out of isolation. Second, broadcast. This is a one-to-all message, sent to every device in the local network segment, like shouting to everyone in a room. Think an ARP request, asking who has this IP address. Third, multicast. there's a one-to-many communication for special groups of devices. Only devices that specifically subscribe to the multicast group will receive the traffic. Like a private club, more controlled than a broadcast, but still reaching many. Now VLANs, or virtual local area networks, are more powerful tools for managing your newfound connections. They allow you to divide a single physical switch into multiple separate logical networks. 802.1q is the industry standard for tagging VLANs in an Ethernet frame, allowing them to traverse trunk links. This means one physical switch can host many isolated networks. This offers enhanced security by segmenting traffic. It reduces the size of broadcast domains, improving network performance, and it provides much better organization and management for your network infrastructure, preventing a chaotic tangle of connections that could pull you back to level 0, the void. But even with connections, chaos lurks. STP, or spanning tree protocol, is absolutely critical for preventing switching loops. Loops are network killers, causing broadcast storms and MAC address instability, devastating symptoms that will most certainly send you plummeting back to level 0. Disconnected and alone. When there's a redundant link in your network, STP intelligently blocks one of them. This ensures a single loop-free tree of active paths is always maintained. It elects a root bridge, determines root ports, designates ports, and then blocks redundant ports, acting as your network's guardian against self-destruction. RSTP is Rapid Spanning Tree Protocol, a significant improvement over classic STP. It converges much faster after a network topology change or a link failure, minimizing the time you spend flirting with digital oblivion. MSTP, or multi-spanning tree protocol, allows you to map multiple VLANs to a single spanning tree instance. This saves valuable switch resources while providing robust loop prevention. It is the best of both worlds for larger, more complex networks, ensuring your precise connection remains stable. Now that we're connected and stable, let's talk about performance and preventing future isolation. Link aggregation is about combining multiple physical Ethernet links into one single logical link. This logical link is often called an ether channel or a port channel. LACP, or Link Aggregation Protocol, is an open standard way to do this, while PAGP, or Port Aggregation Protocol, is a Cisco-only protocol. This technology dramatically boosts available bandwidth between devices, and it adds crucial redundancy. If one physical link fails, the others keep the logical link active, keeping you firmly connected and far from level 0. Link Layer Discovery Protocol and Cisco Discovery Protocol are network mapping tools. They help devices automatically discover information about their directly connected neighbors. LLDP is an open standard, meaning it works across different vendors, while CDP is Cisco proprietary, so it only works between Cisco devices. They exchange vital information like host name, local port, remote port, and device type. These protocols are incredibly useful for your network documentation and troubleshooting, providing the insights you need to pinpoint why you might be disconnected and how to fix it before reaching the void. Data. Beyond just data, we can even deliver power over the network. Power over Ethernet is a fantastic technology that delivers both electrical power and data over the same Ethernet cable. This simplifies installations for many network devices, and it's incredibly useful for IP phones, wireless access points, security cameras, and even thin clients. Cisco's PVST, or Per VLAN Spanning Tree Plus, creates a separate spanning tree instance for each VLAN. This allows for load balancing and more granular control over your network topology. Rapid PVST builds on this, significantly improving conversion speed for each individual VLAN. This means each VLAN can have its own independent route bridge and path, optimizing traffic flow and maintaining your vital connections. Managing VLANs across many switches can be a nightmare. VTP or VLAN trunking protocol simplifies this. It allows you to share VLAN information automatically between switches in the same VTP domain, and it has 3 modes: server, client, and transparent. Server mode allows creation and modification of VLANs. Client mode learns VLANs from a server, and transparent mode forwards VTP advertisements but doesn't participate. But beware, a higher VTP revision number from a rogue switch can wipe your entire VLAN configuration. If that happens, your network will be in shambles, and you'll find yourself back at that terrifying, lonely state. DTP, or Dynamic Trunking Protocol, is a Cisco proprietary protocol. It auto-negotiates whether a port becomes a trunk port or an access port. While convenient, it's generally recommended to disable DTP and hard set your trunks. This gives you explicit control and enhances network security. Leaving it on auto can lead to unintended trunking and potential security vulnerabilities, opening a backdoor for the dreaded disconnect. Finally, a quick look at some historical and niche protocol. CTP is mostly deprecated or very rarely used in modern networks. ISL, or Inter-Switch Link, was Cisco's older proprietary VLAN tagging protocol, 1Q. ISL works by encapsulating the entire Ethernet frames, adding a header and a trailer. VLANs, on the other hand, insert a small tag directly into the Ethernet frame itself. While you might encounter it in legacy environments, 1Q is the prevailing standard today. Lastly, flex links are Cisco's specific alternative to spanning tree protocol. They provide a simple, fast failover mechanism. You configure a primary link and a backup link. If the primary link goes down, the backup link immediately activates. This offers fast conversions without the complexity of STP calculations. It's designed for simple, direct redundancy, offering a quicker path to recovery should you ever slip towards that void.